In this video, I'm going to introduce a tool, the Science Practices Continuum, that will help you think about how to implement practices in your classroom. The Science Practices Continuum was developed by the Instructional Leadership for Science Practices project team led by McNeill, a professor of education from Boston College. To help teachers make better sense of the practices, the project team organized the practices into 3 categories. As introduced in previous videos about the practices, these practices include the investigating practices, sense-making practices, and the critiquing practices. The investigating practices focus on investigating the natural world to collect data that can be analyzed using the sense-making practices to develop models or explanations about phenomena. The critiquing practices are iterative and can occur during any point of investigating and making sense of a phenomenon. It is important to note, however, that these groupings are not static. Based on what opportunities students are given to engage in the practices, the groupings could change. However, grouping the practices in this manner provides a helpful way to identify and think about ways to engage the students in the practices. The investigating practices include asking questions, planning and carrying out investigations, and using mathematics and computational thinking. The investigating practices focus on asking questions and investigating the natural world through planning and carrying out investigations. As part of this, mathematics and computational thinking can be used to investigate science relationships. The sense-making practices include developing and using models, analyzing and interpreting data, and constructing explanations. These practices focus on analyzing the data through the investigating practices by looking for patterns and relationships to develop models and explanations. These practices are less often seen in the classroom than the investigating practices. Finally, the critiquing practices include engaging in argument from evidence and obtaining, evaluating, and communicating information. These practices emphasize that students need to generate arguments based on evidence and defend or revise their arguments based on evaluations from others. Engaging in argument from evidence is one of the least frequently observed practices in the classroom. So that opens the opportunity for teachers to really engage students in this practice and improve their use of practices in the classroom. The Science Practices Continuum is a tool created to assess the quality of engaging students in the science practices and is intended to help teachers identify key features of the practice and student activities. The descriptions on the continuum are simplified versions of the practices provided in Appendix F of the Next Generation Science Standards. There is more to each of the practices than is communicated in the continuum. However, the goal of the continuum is to focus on 1 or 2 elements for each practice that can be challenging for students, but productive for shifting to more sophisticated student engagement in the practices. Another helpful use is to come back to the continuum several times throughout the year to assess the progress of students engaging in the practices. The continuum ranges from level 1 to level 4 for student engagement in the practices. At level 1, student engagement is not present. At level 2, students are beginning to engage in the practice, but is still teacher-driven or the activity is not connected to a scientific context or research question. Student engagement in the practices at the 3rd level is considered to be proficient. Students work effectively with the practices, but may not engage in them in all of the ways that a scientist would. At level 4, students are engaging in the practices in an authentic way. A few weeks ago, you engaged in an activity related to a honeybee collapse disorder. In this activity, you used an agent-based model to investigate different factors that could lead to honeybee colony collapse. One of the intentional practices of focus in this lesson was developing and using models. Thinking back to this activity, how would it be categorized along the science practices continuum? Let's look at the criteria for each level. For level 1, students did not create or use models. For level 2, students create or use models. The models focus on describing natural phenomena rather than predicting or explaining the natural world. Students do not evaluate the merits and limitations of the model. In level 3, students create or use models focused on predicting or explaining the natural world. Students do not evaluate the merits and limitations of the model. And in level 4, students create or use models focused on predicting or explaining the natural world. Students do evaluate the merits and limitations of the model. Here are example questions from the honeybee activity. During investigation 3, You were asked to investigate a combination of factors that could lead to honeybee colony collapse, including landscape, nutrition, pesticides, and disease. After your investigation, you were asked to analyze the data to determine how the bee and flower populations were impacted by the factors that you chose to test. Then you were to provide a claim, your evidence, and explain your reasoning behind your claim about the simulated natural world. Additionally, you were asked to think about how and to identify the limitations of the model. Based on the previously described components of the activity, this would put the honeybee colony collapse activity at a level 4 on the science practices continuum. That is because you used the model to explain something about the natural world, which was colony collapse disorder, and you did evaluate the merits and the limitations of the model. Let's look at another practice, obtaining, evaluating, and communicating information. Prior to the honeybee activity, you were asked to read some articles related to honeybee colony collapse disorder. This information was intended to help you gain context of how the activity was related to a phenomenon in the real world. We weren't focusing on the practice of obtaining, evaluating, and communicating information in this activity. So beyond reading the articles, we didn't ask you to do any further evaluation. For that reason, that would place the honeybee activity at a level 2 on the science practices continuum. And that's okay. Not every activity or even every unit needs to include all of the practices. Likewise, not every activity or unit needs to engage students in the practices at a level 4. However, teachers should work towards engaging students in the practices at a level 4 throughout the year. So this takes time, and you're going to have to scaffold the students in the way that they engage in the practices. But again, over time, you should be striving towards engaging them in the practices at a level 4. And the continuum can help you think about how to do this.